Hello, everyone. Welcome. We're just going to give folks a few more minutes or seconds to join. But while everyone is getting settled, we're going to share a quick poll just to get a sense of who is in the room with us today. So if you see that up on your screen, feel free to throw an answer in there, and we will be starting in just a few moments. Hello, for anyone who just joined, we're giving folks a few more seconds to get settled. But if you see the poll up on the screen, please feel free to throw an answer up there and we'll be starting in just a second. Okay, I think we are ready to share the poll results. So I am just going to publish those very quickly. Okay, and it looks like we have a very heavy presence from carbon project developers, which is not at all surprising. That's fantastic. We have quite a few in the other category, which of course can encompass quite a few things. So thank you all for joining. It's great to have you here. And with that, I'm going to close out of the poll, and I think we're ready to get started. So, good morning, everyone, and welcome to the joint webinar with Upstream Tech and Chloris Geospatial. My name is Lindsay Dubois, and I am the Carbon Partner Lead on the Lens Growth and Partnerships team here at Upstream Tech. I am going to be moderating today's session and also representing Upstream, so you'll be hearing from me quite a bit throughout today's session. And then I'd also like to introduce Florian Reber. Florian is joining us as head of partnerships from Chloris Geospatial, and he will be representing Chloris throughout the presentation. So we're very excited to have you here, Florian. And maybe before we jump in, I'll just take a moment to give everyone a really high level view and some context on what it is we're going to be talking about today. So, as many of you probably already know, Chloris Geospatial has been a data partner of Upstream Tech for several months now, where you can now access Chloris forest carbon data on Lens, which is Upstream Tech's remote monitoring platform. And I think generally in the industry, we can all agree that there is a place for remote sensing tools and remote sensing data in supporting nature-based carbon projects. However, we're all still kind of trying to figure out where exactly it makes sense to incorporate those for each of our individual workflows. So today we're going to be doing something a little different, and rather than speaking to that broadly, we're going to focus in very specifically on the due diligence portion of carbon project workflow, meaning that you might be considering whether or not to invest in an existing carbon project, or as a project developer, you might be looking at all different kinds of areas of land for potential carbon project development. And so, more specifically, we're going to talk about how the combination of Chloris data via the Lens platform can not only elevate your approach to due diligence, but streamline that, make it faster, allow you to consolidate more of that workflow in one place, and ultimately help to de-risk carbon projects. So, with that, I'm going to quickly go to the next slide here. And we're going to have Florian kick us off with a high-level view of the Chloris data and some key considerations that you would want to think about as you assess the fitness of carbon biomass data for all kinds of due diligence applications. From there, I'm going to give a very brief overview of the Lens platform and what we're all about and why we do what we do. And then I'm going to very quickly pivot into the live demo portion of today's session, where we'll go into the Lens platform. We'll show you how and where you can access that Chloris data, and how you can use that alongside a lot of other valuable data sets that can help with the overall effort of project diligence. So with that, I invite you, Florian, to join me. And I will also say, sorry, I forgot to mention, if anyone has any questions throughout the webinar, please feel free to use the Zoom Q&A feature at the bottom of your screen. And we're going to be carving out some time at the end of the session to hopefully address as many of those questions as possible. So with that, Florian, please jump in.
Thank you so much, Lindsay, and yeah, thanks for having me and Chloris as an organization also in your webinar today. Yeah, we are thrilled to be a partner of Upstream Tech, and also a warm welcome to everybody in the audience from my side. Thank you so much for carving out time from your busy schedules to be with us today. So a few slides on Chloris, as Lindsay you just said. As some of you, I'm sure, already know, Chloris, our expertise as a remote sensing company really lies in understanding above ground biomass dynamics over time. So we're talking about above ground biomass time series products. That gives us data on how carbon in woody vegetation, or for shorthand forest carbon, is really changing over time across the planet at any scale desired. And we do this both on the density, so the AGB stock, and also the AGB change, so how it is changing year over year, and also use that rich above ground biomass data set to derive forest cover information in terms of forest, non-forest, and forest area gains, forest area loss, also classifying degradation losses. So that's the core of the Chloris data product. And if we go to the next slide, please, Lindsay. Just a few visualizations, how this looks like. Here, of course, we're looking at a biomass map of Brazil, and 3 zoomed in views here. One very far upstream in the Amazon basin, close to the origins of the Amazon. And you see this is a 30-meter pixel resolution as indicated in the title. Then we also do this at a 10-meter resolution. You see here 2 visualizations again of the biomass stock data, and then also the biomass change. And there you see on the change side, I think this is an interesting part here also for the due diligence process. You see the full spectrum of above ground biomass change experienced by a pixel on an annual basis, with quantified uncertainty attached to it. So full spectrum from, let's say, full losses to partial losses, and then also the gains that you can observe year over year. Next slide, please. So, and today, of course, we talk about project due diligence of forest carbon projects, and arguably forest carbon data plays an important role to understand and assess forest carbon projects. I'd like to say as well that there are, of course, other information that need to be considered. It's not all about the carbon, but of course that's a key a key aspect of the due diligence. And I think then that also begs the question of how trustworthy and how good is the data, the carbon data that you're using for that due diligence, because of course you want to be able to trust the results of your due diligence. So I'd like to point to maybe 4 questions that I would invite users to consider when working with a forest carbon data set for the due diligence. Next slide, please. So I think the first question to ask is how far back in time can you see? Because what you want to understand, one aspect of the due diligence process is the history of that area of interest. And here you see an example of actually a larger area in Peru, where you see the time series since the year 2000. Since this week, actually going until the year 2024, so Chloris now covers a quarter century of carbon history for any area of interest around the world. And so that now gives you a very deep view into the history of a site that you are checking. Next slide, please. So second question, is the data spatially scalable and consistent? the point here is that very often you want to compare a area of interest to another area of interest, maybe another project, or maybe the reference region of a project. And that's the case we're looking at here. On the left side, now you see the cumulative biomass change of the Portel Red Plus project in Pará from the year 2000 to 2024. You see some important biomass loss events that actually happened in the more recent past. On the right side, you see the reference region around that project. And if you look at that reference region, those carved out areas in the upper part of the polygon, those are the actual project areas. And I think at first sight, what you see is that there is a lot more red in the reference region. So like one conclusion to be drawn here is that if that were a project that you're looking at in the current Red Plus world under the current methodologies, you can, I think, draw some conclusions to what extent that project area is at risk of losing biomass, for example. And for you to be able to do that in a trustworthy way, you want the underlying data to be like scalable and consistent in space. Now we can go to the next slide, please. Similarly, how robust is the data over time? So that's more about the temporal consistency and the quality. And here now we see actually a few examples of an analysis we have done on an ARR project that started in the year 2019. It's not a VCS certified project, but planting has started in the year 2019. And you see the graph with the orange frame around it, that's the Chloris data. The other graphs are some of the publicly available vegetation indices. And you see at first sight how much more stable the trend lines are on the Chloris data. That robustness is key to also understanding the baselines and doing dynamic baselining, and specifically on the VM47. So that's that temporal consistency and robustness of the data, of course, adds value also for the due diligence. Next slide, please. And I think now getting to the last part of my presentation, key question, of course, as well is how well does the data represent what's actually happening in the ground? So how accurate is the data? And here, of course, it matters a lot about how the data are being validated at Chloris, and we also validate against independent data sets of higher quality than ours. These here are the validation metrics of our data in the sense internal model validations in the machine learning sense, by region and also by biome type, giving you an indication of the quality of the data. Now going to the next slide, maybe for those who are more visual learners and less learning with numbers. Here, a visual example of how the Chloris data is picking up change. And what you see here, actually, if I draw your attention to the frame in the middle, that is the AGB change map of a project area. And within that red frame, you see some red pixels and orange pixels. And that is an area where some selective harvesting has happened as allowed, as per the concession in this area. And if you look at this area in Google Earth Pro, you see that image on the right, where you do see, if you look closely, these gray stripes lying at the bottom. And these are the stems of the trees that were cut. And I think that's a visual validation of the change that the Chloris data is picking up. And I think that's it. Lindsay, you're on mute. There we go.
Yes, thank you so much, Florian. That was fantastic. Thank you for the great presentation and looking forward to further visualizing some of this great data from Chloris in the Lens platform during our demo. So I am going to try to do this very quickly in 2 minutes and just give everyone a general sense of what Lens is, why we do what we do before we jump into the platform. So at a very high level, Upstream Tech is a software solutions company. We're all about building tools that will scale the pace and the impact of conservation and environmental work being done around the globe today. And what we identified as a unique challenge in the industry when we started doing this is that there's lots of great geospatial out there right now that can be used to help conservation work of all different kinds, but many of those folks are not using it, and that's usually because of one or two very key barriers to entry. The first being that even though much of this data is publicly accessible, you really do need some level of GIS expertise to work with it and to be able to pull it up and analyze it in these very complex desktop software programs. So if you don't have a resource like that on your team, that's often a non-starter for a lot of partners. Secondly, the cost can be an issue. And so thinking about some of the great data that's available from commercial providers that's not public, if in order to get those, so for example, high resolution true color imagery, it would not be at all uncommon to hear that you would need to hit some sort of minimum upfront spend or acreage commitment in order to start working with one of those partners. So for resource constrained conservation teams that we might work with, those are often two big barriers to entry. And so we developed Lens, which is our remote monitoring platform. And what we're really trying to do is empower more people to be able to work with geospatial data within a user-friendly tool. So it's designed to help track changes, visualize trends. There's automated reporting features, make it more easy to share these insights with key stakeholders, and do all of this regardless of your own technical expertise. So we have many GIS folks within that are users of Lens and find value in speeding up their work. But on the other hand, we have a lot of folks who might be habitat biologists and doing in-field work that are able to use Lens. We provide access to both public and commercial data sources within the platform from satellite area and environmental partners. These can then be translated into various insights. You can see a lot of really great examples on the left with everything from true color imagery to remote sensing carbon data to tax parcel data, land cover data, and quite a bit more. And then on the commercial side, we have unique reseller agreements with multiple data sources on that front, many of which are high resolution imagery or the remote sensing carbon data, such as Chloris Geospatial. And in those cases, you can order that data as needed on a very cost-efficient cents per acre basis. So that is a huge value to a lot of our partners where they can just kind of pull samples of that data as they need to and use the public data in most cases outside of that. So we are very much an aggregator of a lot of different data sources in one place. We are a reseller of high resolution and commercial imagery. But most importantly, and what really sets us apart, is that we package all of this up into a very user-friendly platform that is designed to facilitate analysis. So this is really what differs from that traditional reseller model where you might get the raw data in some format and still be up against those challenges I outlined earlier. Rather, we're giving you the tool that makes it easy for you to then flip between these data sets, run analysis on your own, compare imagery, run trends, visualize that in many different ways, and ultimately be able to share those insights with key stakeholders much more efficiently. So essentially, we are an efficient tool in that way. And last but not least, we support a lot of conservation work. So we're currently working with over 250 organizations, collectively monitoring 140 million acres. You can see some of our public partners on the bottom here. In the carbon space in particular, we work with everyone from large carbon credit buyers, such as Apple or Microsoft. We work with carbon project developers. So you'll see a couple examples here with mass reforestation, one tree planted. We also do quite a bit with large nonprofits like the Nature Conservancy, federal government agencies like U.S. Forest Service, and quite a bit more. So with that, We are going to jump into the Lens platform now and focus on some live examples. We have two examples for you. I'll probably be spending most of the time in the first one, which is an afforestation project in Mato Grosso, Brazil, followed by a second example that's a little bit more focused on avoided deforestation in Vietnam. So we're going to use these to kind of simulate what a diligence process might look like within Lens, how to access the Chloris data, and how to look at that alongside some of these other data sets. So with that, I am going to switch over to Lens. And what you're seeing right now is our first property, which is in Mato Grosso, Brazil. And this is an afforestation property. So we're looking at a true color image from late February of this year. And to give you a little context on this property, it's about 1,400 acres in size. That equates to roughly 560 hectares. You have this area of preserved forest here, and then the surrounding area is the afforestation project where you can see that trees have since been planted, and we'll get into that in more detail. This afforestation project took place in 2019, but for the sake of this demo, we're going to go back in time and pretend that we're roughly in 2018 or 2019, and we're considering doing an afforestation project here. So I'm going back to an older image. This one happens to be from 2020. And this particular project area might look a little something like this, where you have the preserved forest area here, and then you can see the surrounding area is pretty barren land that visually appears like it might be good for a potential afforestation project. So one of the things that we would want to review in the diligence exercise here, we'd want to look at historical land use, understand how this land has been used over the last 10 to 20 years, ideally, if there were any changes or conversion in that land use. We would also want to establish that there had been no global forest loss within the last 10 to 20 years, as well as that could potentially impact the value of the carbon credit we're trying to generate. And then we would also, most importantly, want to ensure that the area we intend to plant is not potentially some sort of biodiverse ecosystem where we could have a negative impact on the environment. So the first thing that I'm going to do would be to go into the Lens library and choose the different data sets that I might want to analyze. So we're not going to look at this in detail, but this is our Lens library where we have a multitude of different data layers and overlays you can look at in different categories. Land cover, for example, you can activate any one of these to show up in the portfolio that you might be looking at. Biodiversity, I think, is another big one that's on everyone's mind. So you can see we, of course, would have vegetation, forest insights, hydrology, and a whole lot more. So everything that I've chosen to activate for this portfolio would be listed here. You can see there is quite a bit. And where I'm going to start is to look at some of the land cover data sets to see what the historical land use was. So I'm clicking on analysis over here. I'm going to select the entire property for analysis. And I have access to a few different land cover data sets on Lens. But in this case, because this project is in Brazil, I'm going to use this Map Biomass Brazil. This is a wonderful land cover data set that goes very far back in time. So when I can use this one, I think it's preferable. And then I'm going to click this Analyze button, and it will quickly generate this lovely chart for me. And if we're assuming that we're roughly around here at this period in time, we're going back to the year 2000, we can see that there's been a lot of consistency in how this land has been used. I can click on any one of these time steps or mouse over it to see the percent acreage and area that's considered forest, which is the green here. And I can see the corresponding visual over here. So these are all interactive charts. And I'm just going to collapse that key so it's a little easier to see. So you can see where we have that preserved forest, and then this yellow area is being categorized as pasture land. So that's good news because this is presumably degraded pasture land versus something like grassland, which we might want to investigate more that could be a biodiverse ecosystem. So closing out of this and going back into my true color high resolution data, the next thing I might look at is global forest loss. So again, I'm going to select the whole property, and this time I'm going to choose the Hansen Global Forest Loss data set. This is also really helpful. I quick analyze and it quickly pulls up this chart, which is exactly what I would want to see for an afforestation project. What we're seeing is that there's virtually no history of forest loss on this property, which is great. There might be a tiny bit here in 2019. If I click on that time step, you can see just how small that is, but certainly nothing that would be a red flag for project due diligence. So these are some very quick and early screening efforts that a lot of our partners might do before they consider passing along various areas of land further into the diligence process. So I'm going to go back into the true color data here. And now I might consider to accessing the Chloris data to kind of continue and do some of the good work that Florian spoke to earlier. So as mentioned, we are a reseller of commercial data sets, and you would go to this order button here where you can see the Chloris data here. We've already ordered it for this property, so that is why it's grayed out for the purposes of this demo. But you can also see a lot of other high resolution images that are available at different points in time across all of our different data source providers, such as Airbus, Maxar, Planet. And if I wanted to order one of those, I would click on it and you would see something that looks like this, where we would show a thumbnail of that image at 1,400 acres. This particular data set is 4 cents an acre, and this image would cost me $55. So this is just a good example of kind of how that workflow works. But I've already ordered the Chloris data, and now that is showing up here in my dropdown for analysis. We do offer access to both Chloris's 10-meter resolution data set as well as the 30-meter resolution data set. If you do place an order for these, you get whatever the most current time step is, in addition to all the historical data beforehand, so you can look at trend analysis. And I will also just say that you get 3 different data layers with any of these orders, including above ground biomass or carbon stock, change in carbon stock year on year, and Chloris forest cover. So all 3 of those data sets come with any orders. So with that, I am going to click on analysis once again, but rather than looking at historical biomass for the entire property, maybe I really just want to focus on where I intend to plant. So I'm going to leave this on draw area, and you can see here that I'm able to highlight and kind of click and draw my own shapefile of where exactly I would want to run this analysis. So I'm doing this very quickly for the purposes of the demo. And you can see here, I've highlighted the surrounding area. I'm going to look at the Chloris 30-meter resolution carbon stock data set. I'm going to go back as far back as I can possibly go in time and click Analyze. And what I would see is something like this. So if we're assuming we're looking at this prior to the afforestation project, we'd see that there's been this kind of steady downward trend over time. I could click on any one of these time steps and see a visualization. So the preserved forest obviously is showing strong biomass storage, whereas we're seeing very little on the outskirts. And now at this point in the due diligence process, I would say the visualization of the Chloris data may not be quite as helpful as the raw data itself. So if you click up here, you can see you have the option to export any of these data sets that you're pulling as a CSV and to start working with that raw data for other kinds of calculations, such as carbon baseline calculations. And so I'm going to invite Florian to jump in at this point and maybe give us some thoughts on, at this particular point in the diligence process, how could you consider using the Chloris data for this potential afforestation project?
Thank you, Lindsay. And I was also just replying to one of the questions in the chat. So that's a very good example of not trying to do any multitasking, because Lindsay can call upon you any moment. So yeah, at this time, I think what really is interesting to look at is, the history of the site. And for example, you want to make sure that there wasn't like any recent strong biomass loss, like definitely no deforestation, and you want to see this like over as long a time period as possible. So I think if this is like really just at this point in time when no growth has happened yet, you want to see the history of the site. And then if you have more information already on, let's say, any identified control plots, of course, you can also check the history of those areas. And yeah, so I think for if this is at this point, maybe I will leave it at that. Maybe we can talk more about dynamic baselining for when projects are more mature.
Yep, absolutely. Thanks so much, Florian. That's great. And I will wrap up this particular example in just 30 seconds. I will call your attention to this add a note feature that we have here. This is where you could type in any observation you might be making and associate that with different charts and visualizations that you might have been looking at. And I've taken the liberty of creating a few notes here that really just iterate that same flow of analysis. There are some interesting ones that we didn't talk through, such as a natural lands classification data set that shows that the non-natural areas were planted around the preserved forest. We've chosen to do this compare mode feature where you can kind of look at the true color versus the modeled data set. We know this afforestation area was roughly 700 acres. We talked about the MAT biomass land cover data set, and we're seeing what we would want and expect to see, which is more of this brown color taking over as we get into present day, which is considered forest plantation. So you would expect that that would be growing. We already talked about that there is no record of global forest loss. We took the liberty of ordering an Airbus high resolution, 30 centimeter resolution image to show present day how that forest plantation looks versus the preserved forest area. So these high resolution images can be really helpful to get a good look at what's happening on the ground. The carbon data in the southern plantation would show this wonderful upward trend that we would expect after it was planted in 2019. And the visualization, we have this before and after slider mode. You could visually see how we've been on a positive trajectory of carbon biomass storage. And the northern plantation, we have the Chloris 10-meter data set here, was planted more recently. You can see in this note here, planted in 2022, and you have the before and after. So we can see how carbon stocks are starting to increase, but just a little bit more slowly in this area. So with that, I am going to switch over to the next demo property, and I'm going to go through this one a little bit more quickly. Hopefully that last one you were able to see how quickly you can toggle between different images and pull up different data sets and run those kinds of charts and analysis and save them to notes. So in this one, I'll give you a little high-level context on this property. So this is an avoided deforestation example in Vietnam. This particular area is about 64,000 acres, which equates to roughly almost 26,000 hectares. And full transparency, this is actually a national park in Vietnam. It used to be a natural preserve that was upgraded to a park. So in the world of carbon, this would never be considered for an actual carbon project because it's already protected and therefore you don't have an opportunity to make the case for additionality. So we are using this as a hypothetical example only because geographically we think it's a very good example of what is a very intact forest surrounded by what could be a fair amount of like risky areas adjacent to that property. And what we want to look at, if we assume that we are considering doing something like a REDD+ project here, we would want to make the case that there is a substantial risk of deforestation historically and present day for this forest. We would also want to confirm the presence of co-benefits and identify possibly different opportunities to establish that this is a heavily biodiverse forest. And all of these things would go to the valuation of the carbon credits that we might be trying to generate. So I think from the true color imagery, we can see pretty clearly here that this area is mostly cropland on this side of the property and the forest area. And then you have a more heavily urban presence kind of developing over here. And so if we're looking at to establish that there is risk here, The types of data sets, again, that we would want to look at are various land cover data sets to see what the historical land use trends have been here. We would want to see if there was any history of forest loss in the area and deforestation. We might want to look at other adjacent risks. Unfortunately, in this area, Vietnam slash and burn agriculture is a pretty common practice. So, are there areas of burn that are happening next to these properties? And then, as I mentioned before, we'd want to maybe look at some biodiversity data sets. So rather than running the analysis on each one of those, I'm going to fast track this a little bit. I'm going to go straight into the notes section where we have done a lot of this work. And I'm going to sort from oldest notes to newest right now. So if I click on the first one, we're using WRI's natural land classification model data set, which you can see that the majority of this property and forested area is considered wetland forest. So I think that is a helpful starting point. Then we looked at the Impact Observatory land cover data set. So this goes back to 2017. It's a little bit more recent. The green area would be trees, the orange would be cropland, and the really red over here would be urban areas. And the trends that we're seeing is that the green has been decreasing over time, where the orange has been increasing. So we're seeing more cropland that's been historically encroaching on this forest. And we chose this before and after slider. So before, back in 2017, the property would have looked like this. And we can see as we look at this comparison feature that the orange has taken over most of that open rangeland and has been encroaching on the forest. So we're seeing agriculture as a threat there. Next, we have this other land data set called tropical moist forest layer. And this one's interesting, so I'm going to open this analysis in particular and give you a better look at this. But this is only available in tropical areas, but it divides forest into 6 different categories, from undisturbed tropical forest to degraded forest. The orange would be deforested land, and this neon yellow-green would be tropical forest regrowth. And so this is really interesting, I think, because we can see from, a before and after. If I click on one of these time steps, I can see that back in 2000, this was mostly undisturbed forest. If I click on one of the newer data sets, or let's say we're looking at this in 2016, we can see before versus after. And you can see how that light orange degraded tropical forest has unfortunately been taking over. We've seen more deforestation down here. So I think this not only goes to helping us understand the threat, but I think this can also be used as a proxy for biodiversity as well. So, we can't see actual species of animals from geospatial data in space, but we do know that the likelihood of the biodiversity in an undisturbed forest is going to be quite a bit more than, say, a new forest regrowth area. So that is a really good case, I think, also to show the co-benefits. I'm going back into notes here for a moment. And I am going back into oldest to newest. Global forest loss. We've seen pockets of forest loss on the edges in small bits each year. And this is a really clear example with true color imagery of that being due to a lot of encroaching agriculture. We see burn that coincides with cropland on the outskirts of the property. So while this is loading, we have the comparison of true color imagery, and then this is the Sentinel-2 burn index, which is a public data set where you can really clearly see that burn as a result of ag. We could also look at that in terms of this chart here. This is for a very specific area of burn, but you can see that repeated burn really coincides with what's likely agricultural practices and a threat to this particular area. Last but not least, we have biodiversity data sets within Lens. This is the biodiversity intactness data layer from Impact Observatory. And you can see that this forest is clearly defined as a heavily or intact forest from a biodiversity standpoint. So that means that the abundance of individual species and species composition is really at its highest, and there is a great opportunity for co-benefit incorporation into your carbon credit valuation. So with that, I'm going to click into the Chloris data. You can see the historical trend here for the property is relatively flat. And since protection has really taken hold in 2016, we've seen this nice upward trend. But I'm going to pause here. And again, Florian, sorry to call on you, but I'm going to bring you in, and I would love for you to talk about how the Chloris data could be considered in evaluating a REDD Plus project or something along these lines for avoided deforestation.
Sure. Thank you, Lindsay. So I think here we are obviously in a transition period also like from existing RED projects to the new methodologies such as VM48. And yes, I think so for existing projects, getting an independent perspective on the counterfactual, the deforestation risk, and so how at risk the project really was. I think given the what we said in the beginning about the carbon history and the type of carbon data, also with forest non-forest views and how you see that in the Chloris data, that gives you a fully independent outside-in view on how at risk the project is. And I think that is one factor. Then I think really also like now in this transition phase to, let's say, more modern, the newer generation of RED projects, understanding degradation risks, of course, is an important element here. And being able to account for that is really something that this data now makes possible for the project design, understanding baselines, and also like assessing the viability and the integrity of projects. So that I think is coming together here for the new generation of RED projects. And yeah, maybe just if I can quickly go back to the ARR projects before, where you caught me a little bit like off guard. Definitely, I think the ability to develop like robust dynamic baselining with this type of data is of great use for due diligence and also like just for the development of robust new ARR projects. So not only like seeing the history, but really also like getting a robust stocking index, a low performance benchmark for increased integrity and the additionality of the projects.
Excellent. Thank you so much, Florian. And as you can see from the screen here, we've concluded the live demo version. So hopefully everyone got a sense of what the Lens platform looks like, how it can be a helpful tool in visualizing and analyzing not only the Chloris data, which you can access, but also all of these other data sets that you might want to consider looking at for project diligence. And I will say many of the partners that are working with us today, this was just examples of two individual potential project areas, but many of our partners are assessing hundreds, if not thousands, of these locations at a time. So what is critically important is to scale and speed up that work and make the geospatial component of this easier. It certainly doesn't start and stop with the geospatial component of diligence, but the hope is that you can, green light certain areas to move forward in the diligence process and continue with what will inevitably be necessary to do some in-field diligence work as well. So that said, I think we only have a couple minutes for Q&A. So I have that pulled up, and there's some great questions in here. I'm going to start with the first one, which I also think is a very important question, which is, why would someone order through Lens rather than working directly or subscribing directly with Chloris? And this is a great question. You obviously have opportunities to do both, and we encourage you to do whichever works best for you. So there are certainly some partners that already know that they want Chloris data, that have a very large footprint of project areas that they want to order that for. And it might absolutely make sense from a financial standpoint to be working directly with Chloris on kind of a larger data partnership where you can get that data directly from Florian and team, which is fantastic. I think where Lens comes in, and again, it depends on your needs. If you're not sure that you want to be using the Chloris data, maybe you want to do some testing with it, test against in-field data, this would be a great way to pull samples of it. Maybe you don't have enough of a project footprint that the financials make sense to do a large upfront partnership directly with Chloris and the data provider. And, most importantly, I think, is this analysis tool. So, Chloris, of course, has other partners where you're able to access their data through. What Lens does that I would say the others don't is give you the analysis features and functionality with it. So, if you have folks on your team that are Python coding experts and can, port that through an API directly into other areas that you might want to be using it, maybe there's other solutions that are better. If you're in need of this kind of analysis and visualization tool, and we have a lot of other features we didn't speak to in Lens, such as one-click reporting, I think this solution kind of supports that particular use case. So we encourage whatever to do, to do whatever works best for you. Florian, anything you would add to that?
No, I think that's great, Lindsay. So yeah, let's go to the next questions. There are more.
Okay. Excellent. Next question. I think we kind of already touched on the biodiversity question. Obviously, I see it here, which is, can you speak more to how you would use these for biodiversity insights? Generally, I'll steal your words here, Florian. Biodiversity is more of a concept, not a, quantifiable and measurable data variable. And so there are biodiversity data sets out there, but they tend to be very coarse in resolution, so they're very difficult to manage or to look at on an individual project level for individual project insights. Therefore, we find many of our partners find more value in pulling the land cover data sets to use as a proxy for where, things might impact biodiversity, or visually see what's happening adjacent to your property. So for example, if a neighboring property clears forest that is connected with the forested area on your property, there could very well be a change in the amount of species that move into the forested area on your property. And you would want to potentially recalculate and readdress what the co-benefits of that project might look like. So these are kind of ways you can use geospatial data to address biodiversity, but I think it's something that the industry is still figuring out. And so I think we are a little over time now, and we still have a couple questions that I can see here. So we will do our best to get back to you separately on those. But thank you all so much for your time today. We really appreciate it. I hope that this was helpful. As a follow-up, we'll be sending a recording of the webinar out to everyone, and we will also be providing you with some opportunities to reach out to either myself or Florian directly, and we'd be happy to do a more dedicated demo and a more in-depth demo of either the Chloris data or the Lens platform if you think that would be helpful. So on behalf of both Florian and I, thank you so much, everybody. We really appreciate it. And we hope you have a great rest of your day.